This is All Things Ansys, a podcast from the technical support staff at PADT. Episode 129, PADT's technical support team shares what they find exciting and interesting in Ansys 2024 R2, along with news and events from the world of Ansys. Happy August, everyone. I'm Eric Miller, one of PADT's three owners, and your host for the All Things Ansys podcast. I hope your summer has been going well. Here in Phoenix, we've had an uneventful summer, which is good, but we did break 4 daily high temperature records. But more importantly, we have gone 81 days in a row over 100 degrees with no end in sight. The old record was 76. Worse for me as I get older and look for some relief at night, it was a record 33 days with a low above 90 degrees. And on top of that, June was our hottest average temperature, 97 degrees, shattering the old record of 95.3 set 3 years ago. Yes, I know. I live in the desert. Why are you even complaining? It's what we have to deal with. I need to learn to deal with it. But yeah, it's kind of been a long summer so far, and we're not done yet. Speaking of weather, our employees in Texas and on the East Coast have been dealing with the record highs as well, on top of some serious storms and flooding and some power outages and stuff. So this is getting a bit concerning, but you should know that many people are using Ansys software to minimize climate change or to design for the change that is coming our way. Take a listen to episode 120, where I chat with Ansys's Pepe I always get her name wrong, Maksamovich, outlining how customers are using the tool in a lot of different ways. She's kind of the point person for that work. So definitely follow some of the content she's been putting out there if this weather stuff is of interest to you. There's some pretty interesting things going on. So speaking of older episodes, I was looking at the podcast data, and if you round up, we have 45,000 downloads as of last episode 128. And we started publishing our first one in July of 2017. So I somehow missed the 5-year anniversary, but that was in the middle of COVID, so I'll use that as an excuse. But we've been doing this show now for 7 years. So I want to thank everybody that's been with us for a lot of that, and hope that our new listeners will go back and take a look at some of those older episodes. In fact, speaking of which, our most popular episode is still my interview with John Swanson, the man that wrote the original Ansys program. It was and started the company that is now Ansys and about to be acquired. It has 1,222 downloads. It's quite interesting. He's a fantastic person. And if you haven't listened to it, I recommend you give it a listen. That's episode 35 if you want to go back and hear that one. And if you like this podcast, you want to keep seeing it happen, please let your coworkers know and give us a link on your social media. We really appreciate letting people know about the podcast and adding to our listener base. So more people can learn a little bit more about Ansys, a little bit more about PADT and the whole world of simulation that we all live in. So besides breaking temperature records, the second part of the summer also means that we have a new version of Ansys out. Yes, 2024 R2 is available across the Ansys product family. So we got members of our tech support team who were available on a Teams call, and they each shared the one or two features that have them excited. Let's take a listen and see what's got them interested in what's in Ansys 2024 R2. So here we are before we know it, talking about yet another new release of Ansys. So 2024 R2 is now out and about, and our wonderful technical support team has had a chance to take a look. So a bunch of them that are available today have joined us to have a discussion about what they think is cool and new and interesting in that. So I want to thank everybody for coming. Thanks, guys. And I'm just going to go around the virtual room here by alphabetical order and first name. And if you can just tell us, who you are and what you do for PADT. So we'll start with Alex Moody.
Yeah, hey there. My name is Alex Moody. I work for PADT as an application engineer, and I specialize in the high-frequency electronics section of the Ansys portfolio. So that means a lot of communications applications, RF, microwave, and that includes tools like HFSS, SI Wave, and a lot of the EMA 3D tools.
Awesome. Cool. Christian.
Yeah, my name is Christian Crowley. I am a structural application engineer here at PADT, so do the same thing as Alex, but focus more in the mechanical physics range. So classic FEA, usually in the mechanical platform by Ansys.
That's excellent. It's my favorite part of the tool set. Josh.
Hey there. My name is Josh Stout. I'm an application engineer in systems at PADT. I have a background in mechanical, though. So I've been here 5 years. So I have a decent number of releases under my belt at this point, and I work with tools across the whole suite, mainly focused on non-electrical side of electronics.
Great. Excellent. Very good. Noah.
So I'm Noah Asherbranner. I'm a systems engineer focusing in model-based systems engineering and embedded software. So I work with the tools such as SCADE, Model Center, Medini, and a bit in the digital twin space as well.
Excellent. Very cool. Robert.
Hi, I'm Rob McCatherine. I'm a mechanical AE. I've been with the company for about 6 years, focusing on Ansys Mechanical and the discovery systems, as well as the material side. So Ansys Granta and all that fun stuff.
Very cool. Sina.
Hello, everyone. My name is Sina Gota. I'm also a senior CFD application engineer with PADT for 7 years now. Recently, I interact with customers in aerospace and defense industry more, and different physics, including turbomachinery and combustion. Basically.
Very cool. Fun stuff.
Yeah.
Tom.
Hello, my name is Tom Chadwick. I've been with PADT for a little over 10 years now. My background is primarily in the CFD heat transfer area. I've been using CFD software for a little over 30 years now.
Great. Excellent. And last but not least, Tyler.
Hi there. My name is Tyler Bunton, and I'm a application engineer here at PADT. My background is mostly in low-frequency electromagnetics, so the opposite side of the spectrum from where Alex is. So that's an area that focuses on permanent magnets and their devices, so electric machines, power electronics, wireless charging applications, things of that nature.
Great. Yeah. Well, and as our listeners can tell, we cover a lot of territory now in the Ansys suite, and a couple of our engineers couldn't make it that are covering the optics and some other parts of the code as well. But I think we got enough here to talk about what's new in this second release for 2024. And I'll just start from a physics standpoint with the fluid. Let's start. So since Tyler went last, we'll start first with you. On the low frequency electromagnetic side, what's got you excited? Are there any big new things or stuff that users need to know about in this new release?
So one of the biggest updates to the low frequency side, especially Maxwell, is a new feature of Ansys called Continuum Air. And this is just an improved mesh formulation for doing electric machine modeling. When you have machines rotate, you have to make sure you're sliding the mesh appropriately with it, and that involved a lot of manual effort on the user's part. And they've automated a lot of that to where the new meshing can take care of a lot of that for you, and allow for higher fidelity solves that makes it so you don't have to try and align your mesh and time steps together. Mm-hmm. Another big feature that longtime users will appreciate is an update to the fields calculator, which is a reverse Polish notation calculator, just kind of a pain to use if you don't understand exactly what it's doing. There's now a new methodology of doing that where you can do it as an expression-based formula. So you can write your fields calculations purely with mathematical expressions. Nice. Which is easier both for a user and then also easier to edit if you have to make changes to it. So it's a big improvement that I'm the most excited about, even though it's a little used feature, but it's a very powerful feature.
Yeah. Kind of like CFX always did, and we finally got that in Fluent, right? Yeah. Very cool. Love it. Okay. Well, that's good. And lots of course, we're seeing a lot more usage of the low frequency stuff with the electrification of mobility and aircraft and cars, and everything seems to have motors and actuators and stuff in it. So lots of cool stuff going on there. So I'm glad to see that moving forward. Let's keep in the electromagnetic spectrum. And Alex, what on the high frequency side, what's exciting?
There's a lot of exciting things, but I'll focus in on my favorite tool and my favorite application, which is HFSS and antennas.
Great.
So there's an existing feature that is called the finite array DDM, like domain decomposition. It's essentially just a tool that if you're going to make an array of antennas, usually for some sort of scannable beam, there's a really cool, powerful tool that speeds up the simulation by making the mesh more efficient. But one of the limitations in the past was you could only have a single antenna array in one design. If you wanted more than one antenna arrays, you'd have to do it the old-fashioned way in a less efficient mesh.
Okay.
So there's now a beta feature that allows you to have multiple finite arrays in one design. And so you can stack arrays on top of each other. So you could have like a low frequency array stacked on top of a higher frequency array. And this might be useful, for instance, if you have one array that's dedicated to a transmitter and the other array is dedicated to a receiver, you could have both of those arrays in a single simulation and simulate them using this efficient meshing construct.
Right.
So that's one thing that I think is going to be really helpful to people in that area.
Mm-hmm. Mm-hmm. So like a 5G person would probably be really excited about this if they're doing that kind of communication. Would it fit into that?
If they're designing base stations or anything like that, they would definitely find this useful.
Cool. Very cool. That's that. Anything like that takes something that's kind of this kind of thing when you look at the problem and you go, and you can go, that's not going to be so tough anymore. So that's great. Huge improvement. Good. Let's talk about, let's just totally change and go to some physical stuff and talk a little bit about CFD. So we've got a couple CFD persons on. Either any of you go first. What do you think is really exciting in this release from a fluids simulation standpoint?
Yep. I can go first if
Okay.
Tom is fine with that. So again, I think we're going to have the schedule for the deep dives for each physics soon, but it's just a couple of highlights to make sure that everyone is aware of the main features. So for the fluids and Fluent specifically, GPU is I think third or fourth release that's getting a lot of attention. And it's actually getting a lot of development in the very practical areas. Turbulence models was a bottleneck for people that really solve realistic engineering problems. They want a specific type of turbulence model. So they're adding more and more capabilities in terms of turbulence model to the GPU solver. Helps people with more broad, and more general, basically, or practical engineering problems to use GPU. And UDFs is one thing. You work on a specific problems, you develop UDFs that you kind of have your own tunings or basically little solvers that add to the Fluent. And now UDFs and expressions can be more is more accessible and doable with the GPU solver, basically. So those bottlenecks for many users to switch from CPU to GPU, at least try GPU. Is getting resolved and developed, basically. So GPU is definitely more practical option now for users. Another thing, maybe the web UI is something that a couple of releases Ansys is working on at advertising. So the Fluent web UI in 24R2 is getting a lot of developments, very more easy to interact. And appealing to many users that want to basically go in cloud or use the web interface to try it. Yeah.
So instead of emulating the desktop through a tool, they actually have a web-based interface, so you can get to it in cloud.
You just log in. Yeah.
Nice.
That's exactly. Yeah.
So the big problem on the GPU side is we used to complain that the cryptocurrency people were buying all the GPUs and driving the price up. Now it's all the AI people are driving up the price up. But hopefully it also means more production and more affordable. I just love that. That's fantastic.
Yeah,
big productivity gains there. Good.
Yeah. And Ansys is working on different GPUs. AMD is being worked on also. NVIDIA obviously is the main one, but AMD is being tested, and giving more options to the users.
Yeah, that might be a little bit easier to get hold of than the NVIDIA. Yeah. Tom, what about yourself? What are you excited about on the CFD side of things?
Oh, there are a few things. My background originally was hypersonics, and there's some cool stuff that they're doing in the hypersonics range. Number one, the real gas properties. It used to be fairly cumbersome to build real gas tables for solutions, but now they've got one GUI interface that you can use to access the library of real gas properties and create a table that covers the ranges of pressures and temperatures that you're going to be operating in. So now it's much simpler to do that. It's a cool thing that they've added in the Fluent Arrow modeling tool. Mm-hmm. Now, one of the things that used to be difficult with hypersonic flow is that typically the flow starts out as laminar and then transitions to turbulent partway down your vehicle. And now they've got a Reynolds-based transition modeling, so you can define the range and you can define different turbulence models for transition and fully turbulent. And so you just define the Reynolds number range at which that's going to happen, and it will go ahead and automatically switch turbulence models for the different ranges. One of the other cool things that I've seen is that in battery modeling, one of the issues for lithium-ion batteries is that in destructive situations where the battery is temperature is going up, batteries will start venting gases, and they've got the capability now to model the venting process. So you can run your battery up to a high enough temperature and initialize the venting of the gases and model that.
That's really useful. They do a lot of that testing here at an Ansys user. It's a national company, but name is escaping me right now. But anyway, they're here in town. They do a lot of that pen testing, and I've seen the videos, and it's pretty significant. You want to definitely design away from that, or when it happens, to make sure you can handle it. Yeah.
Right, you definitely got to make sure your system can handle it if the gases start venting without causing the whole battery pack to explode.
That's what I want to avoid. That's very, very cool. Well, and speaking of batteries and that sort of thing, I'm not sure which of you can talk a little bit about kind of embedded systems and that sort of thing. Probably Noah. What's new in that world? Then I'm losing my grip on which tools go into which category, but in your world, Noah, what's new and exciting for the people actually doing the system level programming and such for these batteries and things?
Sure. Yeah. You can definitely, program up battery management software within SCADE. So that's a great segue. This latest update of SCADE has a few things that I'm really excited about. I was initially beta testing one of these features, but it's now available to the public. We've got a Python API that you can use, and it allows you to essentially create a Python package of whatever C code you're actually generating within SCADE. So rather than necessarily needing to interact with it within a C programming language, you can now also interface with it in Python. So I think that's pretty useful, especially for Python developers trying to, enhance and add more. And beyond that, SCADE Suite now also supports a new extension manager that allows you to, work with more Python packages natively within the tool. So definitely helps, make it easier to manage lots of different packages, libraries, etc. And then on the SCADE 1 side of things, they're, working really hard in development, and there's a ton of new UI, UX improvements. But my favorite one is probably the automated test harness generation. So in the initial release of SCADE 1, you had to manually create test harnesses around whatever code you're actually developing. And now you kind of develop the code, and SCADE 1 will kind of build that wrapper or harness automatically for you.
So let me make sure I understand what that is, because we're actually working with a company that makes what I would call a test harness. It's a bunch of wires that go to a bunch of sensors on a aircraft. Is that what you're talking about?
Yeah. So this is more of a digital counterpart, you would think.
Okay.
So essentially the same way that you might have sensors interacting. You know, the SCADE1 test harness will actually account for those different inputs and outputs. So you can, you know, adjust those manually rather than, or automatically, excuse me, rather than having to, you know, manually build up
Each
both
one.
sides. Yeah. Really convenient
That's really
stuff.
useful. Yeah, we're doing some design work on connectors for those, but that's cool to know that they could just go virtual and plan the testing and everything out, I guess, in SCADE, and then build the hardware. Yeah, cool. Love that. Okay, yeah. So kind of keeping in that realm in my head is system level stuff, and you know, poor Josh gets assigned a lot of different new products, but mostly system level. What's going on in your world, Josh, that you're excited about?
Well, I suppose there are a couple things that are relevant here. One would be on the digital twin side. So, of course, that's been an area that Ansys has been focused on developing and improving out for the last several years. This year, I actually saw a pretty major rebranding of a tool that used to be called Twin Deployer. I think it's called Twin AI now. So they're kind of moving in that direction where anything that's AI related is getting branded as AI.
Good.
So most of the functionality is, I would say, the same. The big change that I'm really excited about is Twin Deployer is actually getting the capability of building reduced order models. That used to be done basically entirely through Twin Builder. But now that Twin AI, or formerly Twin Deployer, can do that, you really have an all-in-one solution if all you care about is reduced order models and then deploying them to sort of their end use case. So I think that's a really good change, and I'm excited to play around with it some more.
That is, yeah. It's funny because I'm seeing it digital twin more and more, even to the point where the city of Phoenix did a presentation yesterday. I wasn't able to make it, on their digital twin of their infrastructure in downtown Phoenix. And I don't know if they're using Ansys or not, but yeah, they've got everything, all of their services and utilities and electrical and sewage and streets and everything, street lights and everything in a digital twin now. So it's kind of cool stuff. It's coming out that way. Anything else in your world? Some of the other products you work with?
Yeah, a couple other things. So OptiSlang is kind of a system tool. It's more of a platform automation kind of deal, but we can kind of cross it over sometimes. So OptiSlang has seen some nice improvements this time around. One-click optimizer is one that came out, I think, for the first time a year and a half or maybe 2 years ago. So that continues to receive incremental improvements. This release is no different. It should run, even more efficiently than before. The big change there is that there used to be limitations as far as what starting data you could feed into the one-click optimizer. So basically, every time you ran it in the past, it would need to go through and sweep an initial design of experiments so that it could decide where to go. Now you can bring that in from a prior run, so you don't feel like you're wasting a bunch of effort up on the front in case you needed to run more iterations to get to a final answer. So that part, even without improvements in the algorithm itself, that part should save quite a bit of effort for folks who are doing a lot of optimization.
Very cool. All right. Love it. It says I've talked about that.
Very quick, maybe.
Please go ahead.
Talk about CFP. Yeah, just adding to the OptiSlang.
Yes.
The OptiSlang optimizer, all those capabilities, one click and AMOP, different methods and capabilities. As a built-in optimizer tool in Fluent is now fully released. In the last release, 24R1, it was a beta feature. Okay. Now it's fully released. So again, it's a great tool for optimization, and it's now a built-in capability in Fluent.
Very good. Very useful. Yeah. Don't have to shoot. You don't have to get out the bubble gum and paper clips to connect it up anymore.
Yeah, you don't exactly.
Very cool. Very cool. So we'll come back and talk a little bit more about some of the things we already talked about. But before we do, my favorite area of the code, of course, is mechanical. What's new and exciting there in our vendor, the original Ansys, we'll say.
Yeah, I think there's a couple cool things, and I think we've mentioned this on previous podcasts that mechanical is just so, I just mentioned the original one. It's been around for so long that they're not really breaking the mold and adding new physics types or anything, but so these last two releases, I feel like they've gone a long way in adding some just things that are like, great quality of life features, just things that make sense. For my favorite one, this is a super small thing, but beforehand, when you had like a model and mechanical where you were, maybe you had different analyses, but they're all sharing the same model cell, you weren't able to have different types of contacts or joints or even material assignments across those. Essentially, anything above the mesh level had to be shared by all of them. Something that they're doing this edition is now allowing that even if you're sharing that same mesh, same model, you can turn on and off contacts or your joints or your material assignments for all your different analyses. So you don't have to duplicate the same thing just to change one contact property anymore. So I think that's a great way of, a thing that, it wasn't ending the world, but it was slightly annoying, to have to like duplicate, things that's 99% the same. As far as capabilities that they're adding, I'm really interested at following this as it develops more. They're adding more ways of element removal and mechanical as well. So beforehand, that was mostly done through things like with the ekill APDL commands, which was really just, setting the stiffness of those elements to 0 or near 0 and hiding them from you. Now, coupling with the nonlinear adaptive regime that they've got going on, we're actually having the ability to remove those elements as it adapts the mesh as your part deforms based on some criteria, and then automatically create contact regions for those voids that have been developed. So I know there's been a lot of customers in the past that have asked about that. And it's like, well, we could do this, but it's going to be like a pretty hefty APDL lift to get it working. So this is great. More automation is always going to be good.
Yeah. In fact, I think I remember doing that back in the day. Yeah. In APDL or maybe even Fortran. I'm glad to hear that that's there. That's fantastic. Anybody else want to comment on the structural side of things, or Alice Dyna?
Sure. I'll comment on the structural side. So, as of, I think, last release, but expanded more to this release too, the Ansys sound is now included in Mechanical Enterprise.
Very cool.
So that's in there now. It's no longer floating off on its own a la carte. You get that with it. So if you need to play around with, anything you've recorded or any of your outputs from an acoustic analysis, that is available to do so there, or transfer back and forth. I know it's also available script-wise. I think through was it PyDPF or one of those, or PyAnsys. So that's available too. I'll touch on like a half and half on the materials side as well, is that the materials calibration app seems to slowly be making its way into Ansys Mechanical, or at least through to Workbench. There is some beta options you can turn on to be able to export information over to the GrantMI materials calibration app, which for those that don't know, it's kind of a very easy way of creating material models based on test data things you have that way, and you can then calibrate that out using MAPDL models. So
very cool. That actually is something we may want to use on one of our consulting projects. I didn't realize that was in there. We got a bunch of test data for a rather unusual aerospace material, and we maybe want to take a look at that. So I'll have to look into that. That's kind of cool. So that's the mechanical world, and unfortunately Jim couldn't make it. So we don't. Does anybody have anything to share about LS Dyna, or should we wait till we go and deep dive on that one? I think yeah. Jim's actually in a meeting talking about LS Dyna, so not here. All right, so we kind of covered the big things. Now's a chance. We got a little bit of time left. Is there anybody, just speak up whenever you want? Want to share something else that we didn't get a chance to cover in whatever area of the code you're interested in?
I can take us back to sort of where we started this. So non-electrical side of electronics.
Yes.
One of the tools that I work with most frequently these days is IcePack. Thermal solutions for electronic systems. So there have been a few things there. One of the main driving factors for IcePack is providing an environment for electrical engineers to run thermal simulations without having to learn absolutely everything associated with that. And a common complaint has been the meshing process. And that's definitely something that is always a concern in the simulation, is how do you mesh properly in order to represent what you need. So IcePack has been pushing towards automated mesh approaches. They have honestly been a little bit far behind compared to some other tools. But this release has seen the addition of mesh fusion capability, which basically will let it automatically break down the domain into chunks that make sense to break down. So if you're modeling like a PCB or something like that, and you turn on mesh fusion, it will recognize that, and you'll actually get a mesh through each layer of the PCB rather than some big clunky approximation. So I think that's pretty exciting from just a usability perspective.
That's extremely useful. That can often be more time consuming on PCB simulation than actually doing the simulation. Yeah.
Absolutely.
Yeah. Good. Yeah. Anybody else have anything they want to share?
Sure. I'll go ahead and talk about Discovery real quick here.
Good.
So Discovery has had some kind of major kind of speed ups recently between the past versions and now in terms of just starting and then in loading large models. Additionally, there's a couple features I really like. One's surrounding bolts. So now you can make bolts in the refined mode, the fast GPU solve mode of Discovery, and it will do a AISC allowable stress design check on it. So you can get kind of a really easy visual of what's passing, what's not. And then the other one is the local refinement controls. So if you're doing like anything from structural to CFD side, and you need to, within Discovery, you're used to having that one fidelity slider, and that's your control over how big your voxels are that's being considered. Now you can have multiple sizes. So you have effectively like a face sizing, but it'll expand that to some surrounding area. So you have a lot more control over it.
More control there. Good. Getting more and more. Very, very cool. Yeah. So Discovery, for those that we made a lot of noise about it when it came out. We don't talk about it as much as we used to, but correct me if I'm wrong, because it may have changed since I last looked at it. But it's basically running these GPU-based solvers that are close to real-time solutions, so you can do really quick what-if simulations. Is that still true, or has it moved beyond that?
It is yes and yes, because it's got the extra mode called the refined mode that uses the Ansys flagship solvers. So mechanical, fluent, HFSS, it'll use those too
as well. So in that same interface, it's more for design engineers or occasional users. You can also access the advanced products. So yeah, we definitely need to have a discussion about that so I can get myself educated. No, I saw you come off mute. What do you got to share?
So I wanted to stay kind of on the same topic of, time savings and ease of life. So I'm really excited about the new SysML importer in Medini Analyze. So it allows you to import any sort of SysML model from Ansys or from outside of Ansys. It doesn't discriminate, and it allows you to consume it just natively rather than having to, manually recreate architecture. So huge time saver there. And when you link it with, say, the Ansys system architecture modeler, there's a whole lot of benefits there with regards to push-pull and whatnot.
Just really quick, because a lot of our listeners aren't maybe familiar with it, can you give a really quick summary of what Medini does?
Yeah, so Medini Analyze, it kind of allows you to perform lots of different functional safety analyses for, different systems that might be in, aerospace, automotive, perhaps even in like railway or power generation. So it performs different calculation-based analyses, and then will create lots of great reports for when you submit for certification
stuff. So yeah, I asked that question because I think a lot of listeners are down in the weeds with whatever physics they work with, and maybe not be aware that they can feed into a tool like that, and their quality engineers or failure engineers or whatever you call them are probably maybe still be using Excel, and they need to take a look at Medini. It's pretty.
Oh, absolutely.
The customers we know that use it love it, right? Yeah.
Sure.
Yeah, cool. Anybody else have anything?
Yeah,
Tom.
I was going to say that one of the tools that they've purchased recently, last 3 years, is a tool called Brocky, which is a discrete element modeling, which is different from most of the particle modeling in that the particles are considered actual entities. They can bounce off of each other, bounce off the walls, break up, all kinds of different things. So there are a couple things that they've added into Rocky in the last release. Now it's a fully two-way coupled with mechanical. Mm-hmm. So you can do things like shot peening. You can model the effects on the surface and the behavior of the particles when you're doing shot peening. There's also capability. They've always had a wide variety of different particles. So you could do things like fibers, you can do shells, solid objects, of just about any shape you can imagine. Now they're adding in the capability to do flexible shells, so you can do things like leaves. And you can also couple different entity types together. So you can have a collection of shells and fibers. So you can model things like actual branches and leaves going through a thresher, things like that. And the one other thing is that there is now custom motion frames, so you can model realistic dynamics of moving machinery like excavators and things like that, where you can put in combinations of rotation and translation and all that kind of stuff. So you can model pretty complex systems now.
I will use another 30 minutes gushing about how much I love Rocky. And maybe it's because it reminds me of a video game simulation, because you can do stuff like, branches and things. And it's so cool. I'm not going to go down that road. We will talk more about it in detail, which is a great segue to our finish here, which is that we just kind of done appetizers here. We haven't gone as deep as we could into each of these topics, and we've just talked about 1 to 3 things for each of the more common tools, and there's a lot of tools we didn't talk about. So hopefully it's whet your appetite, who are listeners, and that you will reach out to PADT or whoever you get your Ansys from and ask them for more details. And I always encourage everybody to read the release notes for the products you do use. There's a lot in there that we might not think is interesting, but you may think is like the coolest thing on the face of the earth. So check those out, and we will work our way through a lot of these things in detail as time goes by and talk a little bit more about all these different tools. So I want to thank everybody for taking the time to join me today. I really appreciate it. Hopefully this also gave everybody, our listeners, a little taste of how great our team is and how good they are at communicating this stuff. So I really appreciate your time, guys. It's always special when that many people can join us. It was great to hear from all of them. Hopefully some of you know them from getting tech support from them or having demos from them, but it's always great when they can join the recording session. We will be, as stated, doing deep dives into these codes to learn more, both on the podcast and in our webinar series, which we'll talk about in a little bit. And if you didn't hear something you are interested in, shoot us an email at podcast@padtinc.com, and we'll see if we can cover it. So hopefully we can. For this month's commercial, I want to talk about mentoring. If you were saying to yourself while you were listening to that discussion, I wish I could have access to PADT's tech support team, well, you can with our mentoring services. So if you ever looked at your screen after hours of trying to figure out how to do something or fix something and say to yourself, if I could just get access to an expert to help me work through this, I'd get to the results so much faster. Well, that is exactly what PADT's mentoring is all about. You get access to our team of experts by the hour, and they can help you one-on-one on whatever you need. We have been offering it for over 20 years, maybe a little bit more now. And our customers who take advantage of it, the service, keep coming back for more. They keep renewing it and keep using it, if not growing it. So you do not have to be one of PADT's Ansys customers or even located in the United States. So please reach out to us at info@padtinc.com or our support email, which is swsupport@padtinc.com, and ask about our mentoring services. Mentoring, it's the fastest and most cost-effective way to overcome any technical challenge you face in your Ansys usage. So let's now take a look at the Ansys stock. As you know, Ansys is undergoing the final stages here of being acquired by Synopsys. So kind of weird how it does still go up and down. I guess people are betting that the deal won't happen or will happen, or I'm not sure what. But also, since our last recording of the episode, we had a big dip in the market, right? We had a big crash there for a couple of days, but that seems to have recovered. At least the S&P 500 and Dow Jones are back where they were, and as is Ansys stock. So it's sitting at 325.48, which is still kind of where it's been for a while, and it's below the 390 that Synopsys has on the table for the acquisition. And speaking of that merger, no news there. They couldn't find anything out there. Of course, we don't hear anything at all, probably less than customers do. But everything seems to be moving forward as planned for sometime next year. So that's kind of what everybody's got. But everybody's moving forward as if everything was normal, which is great. So no slowdown on the Ansys side of things while they work through this. Now, Ansys did announce their financial results on July 31st for the first half of the year as well as the second quarter. And that revenue in the second quarter was $594 million, which is up 20% from 2023's second quarter. That adds up to $1,060 million in revenue for the first half of the year. That's up 5.4%, or say 6 million, 1,000,000,006. I don't know these numbers well, but it's a 3% drop, or it's a 5.4% increase of revenue for the first half of the year. Income is down 130 million for the first quarter, or down a bit to 130 for the first quarter, and 165 million for the first half. That's a 3% drop for the first half of the year. This report had a cool pie chart. I guess it's actually a donut chart, because one of those ones is a pie chart with a hole in the middle of it, showing where what they call the annual contract value book. That's kind of what they sold for future over the past 12 months through June was. So the 30% sector, the highest sector, they call 30%, which they call high tech. And I think what that is electronics and things like that, like semiconductor electronics, those sort of things. They kind of lump that all into high tech. So that was 30% of revenue. Second on the list was aerospace and defense at 22%. Automotive was 19%. Energy was 9%. And industrial was 8%. The rest of the sectors made up 12% total of the annual value. That shows they also showed a similar graph for 2023 to kind of show the contrast. And the only real difference in that graph is a 2% growth for automotive. So they're growing in the automotive space, and both aerospace and the high-tech sector are down 1% each to make it all line up. The next area of data that I found interesting was a look at geography. So for the first half of the year, 50.3% of revenue was from the Americas. So that's North America and South America. And then over in Europe, 6% was Germany and 17% was the rest of Europe and the Middle East for 23%. And Japan was 8%. And the rest of Asia was 18.2%. So it's approximately half of revenue comes from the Americas, and a quarter from Europe, and a quarter from Asia. So that's kind of interesting to know. And of course, the American economy is doing better than Europe, so it's not really a big surprise. Of the billion in the first half, $444 million of that $1 billion of revenue was in license sales, and 617 were from maintenance and services. So 60% of their revenue in that first half was from renewal licenses, as well as renewal maintenance type stuff, as well as some services work. They don't break it out further than that. Also, for those of you who are interested, the direct sales by Ansys for the first half accounted for 72% of that revenue. Last year, it was 74% for the first half, meaning that channel partners like PADT are still responsible for a significant amount of Ansys income, 28% actually, in this first half of this year, which is a 2% increase over last year. So we're proud to be a part of that. I also like to finish up by looking at where they are in cash and debt, how strong the company is, how much powder they have, dry powder they have. So at the end of June, they were back up to over $1 billion in cash, $1.1 billion in cash. That's versus $860 million at the same time last year, middle of last year. So nice little recovery there on the cash side of things. And then their long-term debt still sits at around $754 million. So again, the gap between the cash and the debt is bigger as well, which is a healthy sign. So we'll see. I don't know if they'll do any acquisitions before they're acquired, but you never know. We'll see. We'll find out. You'll find out before I do. So in Ansys news, because they were doing their reporting for the quarter, there wasn't a lot. Two things were put out there since our last podcast. The first one was, hey, they released 2024 R2. We talked about that already. And the second was really interesting. It says the title of the press release was Ansys works with Supermicro and NVIDIA to deliver unmatched multiphysics simulation with turnkey hardware. So what does that really mean? I read through it, and my take of it was they sat down with the experts at Supermicro and NVIDIA and built some clusters with and without NVIDIA GPUs, and then did some benchmarking. And some of these numbers are stupid fast compared to CPU only. So the biggest speed up, which kind of makes sense because how good GPUs are with AI, was the AI optimizer that's built into OptiSlang had a 1,600 time increase in speed versus CPU only. Fluent on the benchmarks they ran was averaging about 24 times speed up. Mechanical was a 6x speed up, which is kind of what we've been seeing for a while now. HFSS is getting better with 11% or 11x speed up. And Rocky, for those of you, we talked about a little bit in the discussion session, but Rocky, which is a great piece of software, it saw a 17% increase. So that can be significant for those big simulations of rocks and beans and things. Of interest to me was that LS-DYNA saw a 4% speed up. So we haven't seen a lot of GPU performance numbers for LS-DYNA in the past. So it's good to see that they're working on that. And hopefully we'll see more and more improvements for LS-DYNA solves. That's a little bit more difficult because of the way LS-DYNA does matrices, but I think they'll figure out a way to do it because they have with every other code out there. So that's it. Not a lot of news on the Ansys side of things. On the PADT side of things, we don't really have any news as well. We actually don't have any new blog posts to share with you from PADT as well, because everybody was learning what's new in 2024 R2. So they kind of had their heads down for that, as well as visiting customers and tech support, which is most of their job. And then on the Ansys blog side of things, I'm not going to pick any. Usually I pick 3 and share them, but we spent a lot of time on the financials. So I'll just skip over that and move forward. So let's take a look at upcoming events in the world of PADT. Actually, we did have some news. One of the things we did since the last podcast was we moved all of our webinars from a service that we've been using for many, many years called BrightTalk to Microsoft Teams, and then hosting it on our own website. So that was a little bit of a heavy lift to get all those old, I think there were 74 old webinars over to the Ansys, the PADT website, www.padtinc.com. So we moved the 74, still relevant. There were some that's like, nobody really cares what happened in Ansys release 18, right? But there's some relevant stuff in there that we moved over. And then all future webinars will be done on Microsoft Teams, which should be easier for everybody attending. We're still working out how to make that happen. We haven't scheduled the first one yet, but we'll focus on is talking about what's new in R2 for 2024. So watch however you keep in touch with PADT to make sure you are in touch with when those come out so you can attend them or watch the recordings on our website. Other event wise, really this will go out after there's 2 events at the end of August that will happen after the podcast goes out. But one thing you should be aware of is on September 9th, we will be in booth 517 at the Turbine Engine Symposium, Technology Symposium. So we go to that every year. This is that event is from the 9th to the 12th. And so we'll be in a booth, mostly talking about Flownex, but also Ansys. So if you're going to the Turbine Engine Technology Symposium, please do check us out. I will be in New Mexico on September 10th for the New Mexico Tech Summit. That's their annual event for the New Mexico Technology Council, and I always love going to that. And so I'll be in a booth there, meeting with folks and listening to the great presentations. That's just a one-day event this year. It's been 2 in the past, so they kind of cut it back a little bit. Then I'll be up in Breckenridge, which is not a bad place to go in the summer, for the Rocky Mountain Life Sciences Investor and Partnering Conference. So this is a bunch of startups, a couple of our customers and companies that I mentor are presenting. So I'm really looking forward to that and catching up with that. And then on the 13th of September, Also in Colorado, but this time in Colorado Springs, is the 2024 AIAA Rocky Mountain Section Technical Symposium. I'm really sad that I'm going to be at the partnering conference, so we're going to have some other folks go to the Technical Symposium for AIAA. It's always a great event. Lots of people show up, students, experts. I think I mentioned on the podcast last year, I got to spend 30 minutes talking to the guy that designs the rockets, not the capsule, the rockets for ULA. It's just amazing. This is the head guy, right? And you have access to ask him any question you want. And he really educated me a lot what's going on in that whole rocket industry. So it was really fascinating. There were some other folks there from all sorts of different aerospace and defense industries. So great event. That's September 13th up in Colorado Springs. Then back in Phoenix, I'll be back in town and we'll have a team at the AZ Bio Awards, which is the annual award ceremony for all of our med tech companies in the Valley, or actually in the whole state. A couple customers are up for awards, so hopefully they'll win. We'll look forward to seeing people at that. We'll have a booth for that. And then on October 16th, we're going to be down in Tucson at the 2024 Southern Arizona Tech and Business Expo, which is always a great, well-attended event. The other one that I've been mentioning for a while that I want to really emphasize as well is if you're in Arizona at any time around on October 23rd, well, not any time, but if you're in town on October 23rd, please come to our open house. It's not only our annual Nerdtoberfest, but it's also our 30th anniversary celebration. So it'll be a bit bigger and a little bit bolder than normal. It's at our offices in Tempe. Again, that's October 23rd. Everyone is invited to PADT's 30th anniversary and Nerdtoberfest 2024. And right now, the only event we have at the end of the year is the annual Governor Celebration of Innovation, which is the Arizona Technology Council's big event of the year. It's going to be a great ceremony. We'll have some great keynote speakers, some famous people hopefully will be showing up and handing out awards. So we're looking forward to that. As always, and PADT is the award sponsor for that event. So that's what's going on from an event standpoint. It's a lot. So we'll finish out the year on a bang. Other than that, I think we're done. I think we covered everything we wanted to cover. So I want to thank everybody once again for listening in. Don't forget to subscribe to our newsletter so you can learn more about PADT and what's going on in the Ansys world, as well as the Stratasys and other worlds at www.padtinc.com/opt-in. Do spread the word. Let people know about the podcast. Please have them subscribe. And as always, do not hesitate to reach out. Thank you for joining us for the All Things Ansys podcast, episode 129. As a reminder, this podcast is not affiliated in any way with Ansys Inc., and the opinions expressed are those of the people on the show only and not of their current or former employers. For more information, visit www.padtinc.com/blog, and please share your thoughts and questions through an email to podcast@padtinc.com. See you next time.